Okay, so along with our composition of functions, we're also going to talk about complex and imaginary numbers. So we're going to start out with imaginary numbers. So the unit I is our imaginary number. I equals the square root of -1. So this is how when we get like solutions of the square root of -16, we used to say no solution, but now we can have a solution. It's just imaginary. So I squared would be -1, the square root of -1 times the square root of -1. The square roots cancel out, so that would just be -1. I cubed is the same thing as I squared times I. So it would just be -1 times I. So it's -I. I to the fourth is I squared times I squared. So it's -1 times -1, which is +1. And then I to the fifth is I to the fourth times I. So it would just be 1 times I. So it's just I. So I is I. I squared is -1. I cubed is -I. And I to the fourth is 1. And then these answers just start to repeat. Our I, -1, -I, and 1 all just repeat. So this goes with I to the first, I to the second, third, and fourth. So the way to reduce powers, so if you think about I to the fifth, 5 divided by 4 would be 1 with a remainder of 1. That remainder is which one it is. So we had a remainder of 1, so its answer was I. If you think about I to the sixth, it would be I to the fourth times I squared. We know I to the fourth is 1, and I squared is -1, so it's -1. Or 6 divided by 4 is 1 remainder 2. Since it's that second one, it's -1. So you're not going to be wanting to multiply out like 52 i's, so we're just going to divide it by 4 and determine what our remainder is. So 20 I to the 23rd, 23 divided by 4 gives us 5 remainder 3. 3 gives us -I. 33 divided by 4 gives us 8 with a remainder of 1. 1 means it's I. And then 46 divided by 4 is 11 remainder 2. And remainder 2 gives us -1. So instead of having to multiply these all out, we're just going to divide by 4. Now, complex numbers are written in the form a plus bi, where a and b are real numbers and I is your imaginary unit. So we can simplify down our negative square roots now. So the square root of 16, -16, is the same thing as the square root of 16 times the square root of -1. Well, the square root of 16 is 4, plus or minus 4, and the square root of -1 is I. So now instead of like no solution, the square root of -16 would just be plus or minus 4i. The square root of -28 is the square root of 28 times the square root of -1. And then reducing square roots, this is the square root of 4 times the square root of 7 times the square root of -1. So that would be 2. This gives you I, and then root 7. And of course, all square roots are plus or minus. Now, multiplying imaginary numbers, you multiply your coefficients and you add your exponents, just like if it were like an x. 3 times -2 is -6, I squared. Well, we know that I squared equals -1. So now we have -6 times -1. This gives you +6. Whoops. 6i times 2i, 12i squared times -2i. Or you could multiply it all out at once. 6 times 2 times negative 2 is negative 24i cubed. Now I cubed is I squared times I, and I squared is negative 1. So negative 24 times negative 1 times I, so 24i. So you should never have more than one I in your answer. Like, it shouldn't be I to the fourth because that can be simplified. Now we're going to see how we can use this to solve some answers. So if we have x squared plus 16 equals 0, to solve this you would subtract 16. We have x squared equals negative 16, and you take the square root. Well, now instead of saying, oh no, I can't take the square root of a negative number, you're going to get plus or minus 4i. Lastly, we're going to do operations with these complex numbers. When we're adding, all you do is combine your like terms. So like i's are a like term and constants are like terms, combine them. Subtraction, you distribute your negative 1, then combine like terms just like we've been doing. Multiplication, you multiply it out like normal, but you just have to remember that I squared is negative 1 and replace that at the end. Division is the one where it gets a little tricky. We're going to multiply by something called the conjugate. So the conjugate, all you do is flip the sign that's in the middle of your complex number. So like 3 plus 2i, our conjugate would be 3 minus 2i. 3 minus 2i, our conjugate is 3 plus 2i. Negative 3 plus 2i, our conjugate's negative 3 minus 2i. You don't change the sign in front, just the sign in between them. So for example, addition, we combine like terms. So we have 3 plus 11 gives us 14. Negative 6i plus 7i is plus 1i. And you always write it as a plus bi, so your I term is second. Subtraction, distribute your negative 1. 3 minus 6i minus 11 minus 7i. And then combine like terms. 3 minus 11 is negative 8. Negative 6i minus 7i is negative 13i. For multiplication, we're going to just like FOIL this. 3 times 5 is 15. 3 times 7i is plus 21i. Negative 2i times 5 is negative 10i. And negative 2i times 7i is negative 14i squared. So now we're going to combine these like terms and change that negative or that I squared to negative 1. So we have 15 plus 11i minus 14 times negative 1. So now we have 15 plus 11i plus 14. So now we have another like term we can combine. So we get 29 plus 11i. So this one, just don't forget that I squared equals negative 1. And lastly, our division, you're going to multiply by the conjugate of your denominator. So you never want to have an imaginary number or a square root or anything in your denominator. So to get rid of that, we're going to multiply the top and bottom by 1 minus 4i. Now on the top, we get 2 times 1, 2 times negative 4i, and then negative 3i times 1, and negative 3i times negative 4i. And you can keep simplifying that. Actually, yeah, I'm going to do them separately. So then this I squared is negative 1. Negative 8i minus 3i is negative 11i. And we have 2. Or you can always think about it that I squared flips the sign. So we have 2 minus 11i minus 12. Negative 10 minus 11i is what's going to be up top. So I'm just going to write that over here. Down the bottom here, I'm going to grab a different color. When you multiply this out, we have 1 times 1. 1 times negative 4i. And then 4i times 1. And 4i times negative 4i. these will always cancel out. So you're going to be left with 1 plus 16 because that changes. So we get 17. So this is going to be the same. You never have to multiply out the bottom. So for example, if you have 2 plus 3i times 2 minus 3i, you're going to get 4 plus 9. You're going to get the square root, or the square of your second number plus the square of your second number. Square of your first number plus square of the second number. So if you did multiply it out, 2 times 2 is 4. 2 times 3i is negative 6i. 3i times 2i is plus 6i. And then negative 9i squared. This flips your sign. Those cancel out. 4 plus 9. So whenever you multiply by a conjugate, your answer, it's a plus bi times a minus bi. It's always a squared plus b squared. And then if possible, you could simplify down these numbers, like if you had 10 minus 2i over 2, you could divide everything by 2, 5 minus I over 1. But we don't have that here, so our answer is just negative 10 minus 11i over 17. So whenever you have division, multiply by your conjugate. It's a plus b squared on the bottom. Multiply out your top, and that is your answer. Once again, that was a lot of information, so come to class with any questions you